might throw something a little bit different at you here. The distance formula, distance between 2 points. Some of you may remember the distance formula, some of you may not. If you know where it comes from, you never need to remember, you can always find it when you need it. If I want to find the distance between any 2 points randomly on a beautiful Cartesian plane that I'm just going to draw there for you. Let's say this is my first point, so I'm going to say it has the coordinates x1, the x-coordinate of the first point, and y1, the y-coordinate of the first point. Up here I have x2, the x-coordinate of the second point, and y2, the y-coordinate of the second point. I want to find that distance. The way we do it is we have information about the horizontal displacement of each point, the x-coordinates. We have information about the vertical displacement of each point, the y-coordinates. This distance here, the triangle, is the difference between the second x-coordinate and the first x-coordinate. So that distance there, difference, remember in maths, is subtraction. x2 minus x1. The length of this vertical side is the difference between the y-coordinates. y2 minus y1. So what we have here is a perfect opportunity to use Pythagoras' theorem. Remember Pythagoras' theorem, the square on the hypotenuse is equal to the sum of the squares on the other two sides. In this case, I would write it as d squared equals x2 minus x1 squared plus y2 minus y1 squared. Of course, if you remember the distance formula, you would know that we've actually simplified that even further. And we usually just write it as the distance equals the square root. It's a positive square root, so we don't need to worry about any plus or minus here because the distance is positive. x2 take x1 squared plus y2 take y1 squared. Let's go ahead and do this. To ensure you get it right, it doesn't hurt to call that x1 and y1, and this point x2 and y2, just to make sure you don't accidentally go 3 minus 1 and 5 minus 4, which happens a lot, I've got to say. At any rate, here we go. x2 is 4 minus x1 is 1. So I've got 4 minus 1 squared plus 5 minus 3 squared. 4 minus 1 is 3. When I square that, that's 9. 5 minus 3 is 2. When I square that, that's 4. And so I have d equals root 13. We don't want to go and write an ugly decimal. Exact answers are preferable. So leave your answer like that unless there's a specific instruction to find the answer to a certain number of decimal points or decimal places. Sorry, an exact answer is the best. We've got the second question in there. I only kept it so you could see all of the writing there, but we might as well go ahead and do it. Without all the explanation, you'll see that it's actually pretty quick. So in this case, if I was doing it with the bare minimum amount of work, I would go the distance equals x2 minus x1, 3 minus 0 squared, plus y2 minus y1, negative 5 minus 0 squared. You're good enough to do that in your head. 9 plus 25 is 34. The distance is root 34. That would be the absolute minimum acceptable working. Hope that helps. Cheers.